All right, so we're answering this question before us. It's asking us to solve 2 cos of theta on 2 minus the square root of 3 is equal to 0 if theta is an element of negative 6 pi to 6 pi. Okie dokes. So let's see if we can do this. It might take us some time. The first thing that we're going to do is just rearrange it. Perfect. So that's a bit more pretty. We've got this trigonometric ratio there, which we need. And we've also got theta is an element of negative 6 pi to 6 pi. Okay, once I've done that, the next thing that I'm going to realize is that, do you see here how I have a coefficient in front of my theta? I need to get rid of that. So I'm going to let, now you can let it be any pronumeral. It could be w. Let w be equal to theta on 2. And we also need to get our domain in terms of w as well. And to do that, what I'm going to do is get this theta into theta on 2. So I'm going to have to times it by a half. And that means I also have to times this by a half and this by a half. So that means I'm going to get theta on 2 is an element of negative 3 pi to 3 pi. Once I've done that, I can now rewrite what I've been given in terms of w. So cos of w is equal to the square root of 3 on 2, where w is an element of negative 3 pi to 3 pi. Okay, once I have that now, I can just solve this as I would a normal trigonometric equation. So I need to figure out what my reference angle is going to be. Hopefully you can look at this and immediately recognize that your reference angle is going to be pi on 6, because cos of what angle will give me the square root of 3 on 2, it's going to have to be pi on 6. But if you can't do that, just get your special triangle and you can use your special triangle to figure that out. What you're also going to have to figure out is the quadrants for which you're going to exist in. So let's just draw ourselves a quick sketch of the unit circle. Again, you might be able to do this in your head, which is fantastic. Now, cos is my x, and I need to exist at the square root of 3 on 2, so that's positive, so it's going to be here. Oh, let me do this as dotted lines. Whoops, there we go. Give me 1 second. So that is right there, the square root of 3 on 2, so it's going to be there and there, so it's going to be here and here that I'm looking at. So it's going to be my first quadrant and my fourth quadrant that I care about. Okay, having now done that, I can now say that w is going to be equal to, well, pi on 6 is going to be my first one, pi on 6. And then in my fourth quadrant, what is it going to be? Well, in my fourth quadrant, pi on 6 is 11 pi on 6. And now this is where you have to be careful, because I've got this domain of negative 3 pi to 3 pi. So far I've only gone to 2 pi. So in other words, I've gone here, and I've gone here. But now I need to go back to this point right here to get to 3 pi, because I need to consider all of that. So to do that, what I'm going to do, let me grab another color, is I'm just going to take one of them and plus 2 pi onto it. And if I plus 2 pi onto that, that's going to take me to 13 pi on 6. Now, we go no further. We go no further, because if we go past 3 pi here, we're outside the domain. And you can actually see that you've done it wrong if you did go too far. So let me just show you. Don't write this in. So don't write this in. But let's just say I added 2 pi onto this. Well, what's 11 pi on 6 plus 2 pi? Well, that's going to be 11 pi on 6 plus 12 pi on 6 is going to be 23 pi on 6. And it's quite clear that I've gone over 3 pi there, haven't I? Because 18 pi on 6 would be 3 pi. So this is, 3 pi and a bit more. I've gone over 3 pi. That's bigger than 3 pi. So that can't be right. So that's another way you can check. Just be very conscious of whether or not you've gone beyond what you should have. Okay, we also need to go backwards. We also need to go backwards here. So let me just get rid of some of these lines just to help me out. I need that one back. We also need to go backwards. So we need to go clockwise that way, and then right around to there. Now, you can probably tell that what I'm going to get is negative pi on 6, negative 11 pi on 6, and negative 13 pi on 6. But if you also wanted to, what you could do is you could subtract them from each other. So what I mean by that is, if I just write it in first, negative pi on 6, negative 11 pi on 6, and negative 13 pi on 6, because I'm going backwards. Sometimes, you can do that. Other times it's more helpful to actually go, all right, if I take this and I subtract 2 pi from it, I'm going to end up there. If I take this and I subtract 2 pi onto it, I'm going to end up there. And then you'd actually have to take that and subtract 2 pi onto that as well. As you can see, it gets a bit messy subtracting 2 pi from it, but that's another way to think about what you're doing there. You're subtracting 2 pi until you get to what you want to get to. And again, by going to negative 13 pi on 6, I haven't gone over my domain, which is negative 3 pi. Okay, once I've done that now, I need to get my answer back in terms of theta. Because remember, the answer is in theta, the question's in theta, so my answer needs to be in theta. We'll do this slowly. There is a way to do it quicker, but we'll do this slowly. W is equal to theta on 2. So what I could do is simply write out theta on 2 and just literally write out what I've written here. 13 pi on 6, negative 11 pi on 6, negative pi on 6, pi on 6, 11 pi on 6, 13 pi on 6. I then want theta by itself. To get theta by itself, I need to get rid of this 2, so I'm going to have to times everything by 2. If I times everything by 2, what I'm doing is really just halving the denominator. Okay, so this is going to be theta, and this will now be negative 13 pi on 3, negative 11 pi on 3, negative pi on 3, pi on 3, 11 pi on 3, 13 pi on 3, and those right there are my answers. So I've got it in terms of theta as I needed to. As I said, there's a quick way to do that, and that is basically just ignore this step here. You can think in your head, well, I know that W is theta on 2, so I just need to times it all by 2, which is halving my denominator. It's another way of thinking about it, just to make your life a bit easier. If we were to picture what we've actually done here, let's bring up Desmos. So as you can see, I have graphed this line here. So cos of x on 2 for my relevant domain. Remember, it was from negative 6 pi to 6 pi. Then I've got my line here, and we can now check the intersection points. Negative 13 pi on 3, negative 13 pi on 3. I've got the other one here, negative 11 pi on 3, negative 11 pi on 3. I've got the other one here, negative pi on 3, negative pi on 3, pi on 3, 11 pi on 3, 13 pi on 3. So as you can see, we've done it correctly. So by sketching it on Desmos, we can just confirm what we know, and that is that we've done it correctly. Hopefully you feel comfortable with doing these. As I said, these are tricky ones, but with more practice, you'll become more comfortable and confident with these questions.